Okay, this is... There we go. Wait, something went wrong. Okay, let's try that again. There we go. Now I've got my tools. Editing. Okay, so again, we're just on day 2 of 2-2. Okay, again, we're going to use those angle relationships to prove lines are parallel. The first thing you need to do is on that separate sheet of paper I ask you to take out, and you just start to draw this. This is one of the examples that you're going to see, or not the exact example, but something very similar on your test. So it says, are E and F parallel? Justify your answer. So here's E, here's F. 2x plus 10, 3x plus 30, 5x minus 20. So when we solve for this, we need to go with the guarantee. If we're proving they're parallel, there are no guarantees with those same side interior angles. Okay, so what is a guarantee? Who can tell me? What's guarantee? Yeah, what? Good. The vertical angles, those are guaranteed to be congruent. So that's what I'm going to use here. So I'm going to take 3x plus 30 equals 5x minus 20. I'm going to subtract the 3x from each side. And that means I'm going to have to add the 20 to each side. This leaves me with 50 equals 2x. So I get x is equal to 25. Now, in order to confirm if these lines are parallel, these same side interior angles have to be what? Good. They have to be supplementary. Very good. So I'm going to substitute that in. So this will be 2 times 25 plus 10. That leaves me with 60. This is going to be 3 times 25 plus 30. So that's 75 plus 30. That's 105. If I add these up, do they add up to 180? Do they? No, right? They add up to 165. So they're not equal to 180. So that means E is not parallel to F. Questions on this? Anybody still writing? I don't want to move ahead unless you guys are done writing. Okay, I see. Gotcha. We caught up? All right. All right, so now here is your next one that you try. All right. Now remember, this looks like they're not parallel, but do we always trust the picture? No, we trust the math behind the picture. So I'm going to substitute this stuff in for you guys. So here is 5x. This guy ends up being 7x minus 12. And then we have 3x plus 20. All right, I want you guys to solve for this. What's the guarantee here? Because we don't have vertical angles this time. So what's the guarantee? Someone tell me. You know.
If the lines are parallel, 5 and 4 will be congruent.
I'm sorry?
If the lines are parallel, 5 and 4 will be.
Okay, but we can't really use that. We're trying to prove that they're parallel, so we can't use that just yet. So what's the other guarantee we got? What could we use to solve for this? What about 5 and 6? God, oh, did you have it? God. Yeah, 5 and 6 have to be supplementary, so there's your guarantee. So solve for x using that. Like that's something that won't change, whether we have parallel lines or not. So why don't you solve for that one? All right, what do we have? Are these parallel or are they not parallel? Who's still working on it? Okay, I'll give you another minute. All right, anybody still working on this? Okay, one more minute. All right, are they parallel or are they not parallel? Seen a lot of people shake their heads no. So yeah, they're definitely not parallel. Someone tell me though, what did these two add up to? Good. I didn't get 108. I got like 156 or something like that. Because I got 16 for X, right? No? Yeah, first hour. What was it? You got 14? All right, let's check it out. Let's make sure. Because I might have, maybe I made an error on my post-it. So we have 5X plus 7X minus 12 equals 180. Combine those, that's 12X minus 12 equals 180. I'm going to add 12 to both sides. So I get 12X equals 192. If I divide both by 12, sorry, calculator. 192 divided by 12, I've got 16. Anybody else get 16? Okay. Yeah, so X was 16 here. And then substituted in, I think it was 156. Okay, questions on that? Okay. Anybody still writing? Because I am going to clear it. All right, take out your companions. All right, so let's talk about this first two-column proof. So it says, write a two-column proof to prove the converse of alternate interior angles theorem. So here's the deal. They're giving you that the alternate interior angles are congruent. But what this means is you cannot use that to prove that it's true. You got to use something else. Okay? This is not a one and done type of proof. So in this case, the first thing we're going to do is we're going to have our given. Okay? We're going to have angle 1 is congruent to angle 2. Then I'm stating angle 1 is congruent to angle 3. Why is that though? What's the reasoning? Good. Vertical angles are congruent. Very good. Or you can state the vertical angles theorem. Both work. All right, so now here's our next one. Our next round of reasoning states that we have 2 is congruent with 3. So here's 2 and here's 3. Why would I state that those are congruent? And do not tell me they're corresponding angles, something else. Good. They're transitive property. If you guys look right here, 1 and 1, those are your pairs. That means 2 and 3 have to be congruent by the transitive property. Now that I've proven those congruent, I can state that these 2 are parallel by what? And now you can use something else. You can use the thing I just said you couldn't use before. What is it? Good.
Converse of corresponding angles theorem.
Very good. Converse of corresponding angles theorem. All right, anybody still checking this out? Any questions? All right, here is your try it. So again, we're going to write a 2-column proof for theorem 2.6, which is the converse of the same side interior angles postulate. So we are starting with the measure of angle 1 plus the measure of angle 2 equals 180. Okay, so we're looking at these. And we're trying to prove that L is parallel to M. So here is our given. And then we're going to state that 1 and 3 are linear pairs. And then we're stating the measures, the sum of the measures equals 180. What's the reasoning for this? What's the reasoning for orange? Who can tell me? Go ahead. Definition of linear pair. How about the third part? What's the reasoning for green? Go ahead. Linear pairs theorem. Nice job. All right, so there's the first half of the proof. All right. So let's take a look at the next. So now I'm saying the measure of angle 1 plus the measure of angle 2 equals the measure of angle 1 plus the measure of angle 3. What's my reasoning? There's technically 2 that would be valid. Give me one of them. Nobody knows? Ouch. Guys, your next proof on this test is blank. Nada. Nothing. Help me out here. Show me you at least know these definitions. What is it? It's substitution property. What's the other one that could potentially be used? Someone knew. Go ahead. Transitive property. Those are the only two. And the transitive property works because your pair, remember, 180 and 180. Okay? Now, what's going on? Part 5 in purple. Measure of angle 2 equals the measure of angle 3. What happened there? What property is that? Someone knew. Go ahead.
Subtraction property of equality.
Perfect. Subtraction property of equality. Then we state in pink that angle 2 is congruent to angle 3. Why? Someone knew. Boy. God. Definition congruent angles. Nice job. All right. So now that we know that 2 is congruent with 3, how can we prove the lines parallel? Someone knew. I have to get a beach ball in here. No, gotta be new. Someone knew. I love the enthusiasm, though. Thank you for raising your hand. So how do we prove? We're talking about providing this actually gives me what I need. We're talking about this being congruent with this. That's what we just proved. What kind of angles are those? And how do we prove the lines parallel? Go ahead, Tyler. Or restart.
Converse corresponding angles.
Very good. There it is, guys. Question on this? Anything? All right. We're going to move on. Anybody still writing? 3, 2, 1. All right. So the edges of the new sidewalk must be parallel in order to meet accessibility requirements. Concrete is poured between straight strings. How does an inspector know that the edges of the sidewalk are parallel? All right, so they're saying since the two 53-degree angles are congruent, okay? I know they don't have them listed here. We'll have it listed on the next page. He can apply the converse of alternate exterior angles theorem. The edge of the sidewalks end up being parallel. So now what I'm going to do is this next one we're going to draw a picture for, okay? To help explain it a little better. So draw this in your companion for this try it part. They're telling you this is 53, and then therefore that vertical angle is also 53. So what is the measure of angle 1? What should angle 2 measure be in order to guarantee that the sidewalks are parallel to the main street? So here's the street, here's the sidewalk, here's this. All right, there's our transversal. So someone tell me, in order to prove that these are parallel, okay, what does 1 have to be? Good. 127. Was 2 have to be? That should be pretty easy. 53. Okay, and then you can use they are both same side interior angles, so we're good there. As long as they are supplementary, we're set. All right. Any questions on this? All right, I want you guys to go. This is just, just restating those 4 rules. I know we had 6 total with those half sheets from yesterday. But this just restates everything that was stated before. So I want you guys to work on page 42, 1, 2, and 4. We'll go over that in a few minutes. All right, show of hands. Who's still working on these three? Anybody? All right, big reveal. Number one, what angle relationships can be used to prove two lines intersected by a transversal are parallel? Someone give them to me. There's a total of 4. Ooh. What'd you get?
Uh,
Go ahead.
Converse, same side interior, converse of those.
Okay. So corresponding alternate interior, same side interior, alternate exterior. Those are the 4. And again, we use all the converses to prove that the lines are parallel. All right, Naomi wrote, if angle 1 is congruent to angle 2, then by the converse of the same side interior angles postulate, line L is parallel to line M. Explain the error in Naomi's reasoning.
It has to be if measuring angle 1 plus measuring angle 2 equals 180.
Perfect. She should have written measure angle 1 plus measure angle 2 equals 180. Very good. All right, number 4. How is theorem 2.9 a special case of the converse of corresponding angles theorem? Why is that a special case? 2.9 is the one with the perpendicular. Yeah.
Because the transversal is a perpendicular bisector.
Well, not a bisector because we're dealing with lines, right? So it's just perpendicular.
Yeah.
All right, so yeah, good job. So it says the converse of corresponding angles theorem applies to corresponding angles with any measure, but theorem 2.9 applies just to right angles. Okay. Okay. Students and classes. Okay. All right. Your homework is on Realize today. All right. Hop on. Get going on that. You still have those 2 Google Forms also. I am going to assign the other one to help you with proofwriting with parallel lines tomorrow. Okay? Just like we did before where you're putting in, I want to make sure you guys understand those properties before we get into some of the blank stuff. Okay? All right, that's it. Those of you watching at home, have a great night.